All right, let's jump right in. I want you to imagine something. A single master key. But we're not talking about a key for a building, no. This is for an entire digital kingdom. A key that can unlock every single door, every vault, every secret. And it's forged from the very system that's supposed to protect everything. You might think this sounds like science fiction, right? Well, it's not. This key has a name, and in the cybersecurity world, we call it a golden ticket.
I mean, really think about that for a second. We're not talking about guessing a password or finding some temporary glitch. This is about creating a permanent, all-powerful key that gives an intruder the same level of access as the people who built the system. It's a true skeleton key for our digital world. The answer to that scary question? Well, it's got a name, and it sounds just as tempting as it is dangerous: the Golden Ticket attack. It is, hands down, one of the most powerful and persistent attacks you can run against a network. So today, we're going to break down exactly how this digital heist gets pulled off.
So what is this thing really? See, this isn't just about getting in. It's about staying in without anyone ever knowing you're there. It's all about creating the ultimate hidden backdoor right into the heart of a network.
Okay, so at its core, a golden ticket is a fake authentication token, a forged Kerberos ticket that's used in Windows networks. But here's the kicker. It's a perfect counterfeit. It completely fools the system into thinking the holder is a top-level administrator with keys to absolutely everything. It literally turns the attacker into a ghost in the machine, somebody who can go anywhere, do anything. They have godlike powers over the entire domain.
You know, every great heist needs a blueprint, right? Well, to forge a golden ticket, an attacker can't just wing it. They need a very, very specific shopping list of critical info that they have to steal from deep inside the network's core.
And here it is. This is the list. 3 key ingredients. Now, the first two, the domain name and the domain SID, which is kind of like the domain's unique serial number, they're actually pretty easy to find. But that third item? That's the crown jewel.
Now, this is where it gets really interesting, because it highlights this kind of crazy paradox. To get that KRB TGT hash, which is essentially the master password for the entire authentication system, the attacker has to already have deep privileged access. We're talking domain admin rights. So you see, this isn't an attack to get in, it's an attack to stay in forever. They literally have to be inside the vault to figure out how to build their own permanent key to it.
All right, so once the attacker has all 3 ingredients from their little shopping list, the forgery can begin. This is the moment where all those stolen bits and pieces are put together to craft the master key itself.
So let's set the stage. We've got a regular user, we'll just call him Steve. And as you can see, if Steve tries to access the most important server on the network, the domain controller, he's denied. Makes sense. He's just a standard user, no special privileges at all.
Now, the attacker, who's already gotten admin rights somehow, uses this really powerful hacking tool called Mimikatz. With just one command, DC sync, they can basically trick the domain controller into handing over its deepest, darkest secret, that KRB TGT password hash. This is it. This is the moment the master secret is officially stolen.
And boom, here's the final step in the creation process. The attacker takes the domain name, the SID, and that stolen KRBGT hash, and they just feed them into another command, Kerberos/Golden. And they can even assign this new, all-powerful ticket to any user they want, even our totally unsuspecting user, Steve. Just like that, the golden ticket is forged.
So the key's been forged. Now it's time to actually use it. And this right here is where you see the true, terrifying power of the golden ticket get unleashed.
Just look at this transformation. The attacker loads that forged ticket into their computer's memory. Now, on the outside, they still look like Steve. Nothing has changed. But on the inside, whoa! Their privileges have skyrocketed from standard user to full domain admin. That access denied message, it now says access granted.
And with that access, the entire kingdom is theirs for the taking. They can browse the domain controller, get to every single file, and even steal the ntds.dit file. You should think of this file as the crown jewels of the whole network. It's the database with all the password information for every single user. At this point, it's total, absolute compromise, game over.
So the attacker's in. But the real danger here, the thing that keeps security pros up at night, isn't just about getting in. It's about staying in. It's about becoming a permanent, invisible ghost in the machine.
By default, any guesses how long this all-powerful key is valid for? An hour?
A day? No. A golden ticket is typically valid for 10 years. A full decade. A decade to just silently siphon data, manipulate records, plant other backdoors, all while being completely invisible.
So what makes this so bad is this combination of things. You've got extreme persistence. That's a backdoor for 10 years. It's reusable, so they can come and go whenever they want. It's stealthy, because to the system, it just looks like a totally valid administrator doing their job. And maybe, most important of all, it survives normal security procedures. You can change Steve's password 100 times. It does absolutely nothing to get rid of that ticket.
And this quote really just sums it all up, doesn't it? This isn't a smash and grab. It is a permanent foothold. The golden ticket is how an attacker makes sure that even if you find them once, they can always get back in. They just become part of the network's background noise, which makes them incredibly hard to find and even harder to kick out.
Which leads us to our final, pretty chilling thought. When an attacker can look just like a legitimate administrator, and they're using a perfectly valid key that lasts for a decade and doesn't care if you change the password, how in the world do you hunt a ghost that looks just like everybody else?